What if the rarest secret of our species isn't buried in ruins or carved on stone, but flowing quietly inside you? A mutation so strange it rewrote the rules of survival. It vanishes across entire continents, yet endures in scattered pockets where it shouldn't exist. And against every law of evolution, it refuses to die. When scientists first uncovered it, they were stunned. A missing protein, gone entirely from the blood of millions of people. Not an illness, not a defect, just absence. And somehow that absence became one of humanity's greatest enigmas. They called it Rh-negative blood. By all logic, it shouldn't have survived. For most of human history, this genetic quirk was lethal, a silent killer of newborns, a curse written into the womb. Before modern medicine, thousands of infants died each year from Rh incompatibility. Yet generation after generation, the trait persisted, not fading, not mutating away, but holding its ground like something ancient that refused to be erased. So why did nature keep it? What unseen advantage made this dangerous bloodline worth the risk? Was it protection against forgotten plagues? The genetic fingerprint of Ice Age survivors who outlasted extinction? Or evidence of migrations and civilizations swallowed by rising seas? Whatever the answer is, this isn't just a medical mystery, it's a survival story written in our DNA. A story that links prehistoric hunters, medieval survivors of the Black Death, and even the modern hospitals that still depend on the rarest blood on Earth. Before we climb deeper into this genetic puzzle, what do you think? Does DNA reveal who we are more truthfully than borders or language ever could? Drop your thoughts in the comments and subscribe, because here on Savage Past, we go deeper than history dares. On the wild western edge of Europe, between Spain and France, lies a land of cliffs, forests, and storms. Its people speak Euskara, a language older than Latin, older than Greek, a language with no known relatives on Earth. And their blood is just as mysterious. Globally, about 15% of people carry Rh-negative blood. Among the Basques, nearly 35%. Modern DNA studies, led by Harvard geneticist David Reich, reveal something extraordinary. Basque genomes have remained unusually stable for almost 40,000 years, while new populations swept into Europe. Farmers from Anatolia, warriors from the steppes. The Basques stayed largely untouched. Their bloodlines trace back to the Ice Age hunters who clung to mountain refuges while glaciers covered half of Europe. And when scientists sequenced the 5,300-year-old mummy known as Ötzi the Iceman, they found genetic echoes still alive in modern Basques. Proof that this was no isolated tribe. They are a living time capsule. Guardians of a bloodline older than farming, older than cities, older even than the pyramids. Global hotspots and strange disappearances. When scientists mapped Rh-negative blood around the world, the pattern made no sense. It didn't spread evenly like most genetic traits. Instead, it clustered in a few isolated pockets, then vanished entirely beyond them, as if someone had drawn invisible boundaries across the Earth. In Western Europe, it lingers like a fingerprint left by Ice Age hunters. Frequencies climb as high as 30% in regions like Ireland, Scotland, and the Basque Country. Across the Mediterranean, it appears again among the Berber tribes of North Africa, and in fragments through Western Asia, among ancient Jewish and Arab lineages. But travel east and the trail collapses. In China and Japan, Rh-negative drops below 1%. In sub-Saharan Africa, it nearly disappears, less than 0.3%. Then, unexpectedly, it reappears across the ocean, among the Blackfoot and Blood tribes of North America, where it rises again to around 10%. How did a blood trait that's nearly absent in Asia show up in native peoples thousands of miles away? The migration map doesn't fit. The story we've been told about human expansion doesn't match the evidence in our veins. Some researchers call this the Eurasian boundary, a genetic wall where Rh negative simply stops. Was it erased by natural selection? Was there an ancient split before the gene could spread east? But even if these migrations explain where the blood spread, they don't explain why it survived. Because biologically, this trait should have died out thousands of years ago. It's rare, recessive, and dangerous. So what hidden advantage made it worth keeping? To find that answer, we have to look at the one place evolution never stops testing us: childbirth. For women carrying Rh negative blood, pregnancy itself became a trial of survival. If the child inherited Rh positive blood from its father, her immune system might see it as an invader and attack it. Without medical intervention, that reaction could cause anemia, stillbirth, or death. For most species, that kind of reproductive cost would erase the mutation from the gene pool, but it didn't. Somehow, through tens of thousands of years of famine, war, and disease, Rh negative endured. It had to have offered something in return, a counterweight powerful enough to justify the risk. And what could possibly balance against the loss of life? The answer, scientists suspect, lies not in childbirth, but in death itself. Because when the plagues came, this blood didn't just survive, it resisted. For generations, the Rh negative gene should have been erased. Every childbirth was a gamble, one that nature rarely forgives. And yet, instead of fading, the trait spread through entire populations. It was as if nature herself had chosen to protect this bloodline. But from what? Scientists searching for clues turned not to the womb, but to the battlefield of infection. Because for most of human history, death didn't come from predators or hunger. It came from the microscopic world. Parasites, plagues, pandemics that reshaped civilizations. One parasite in particular stands out: Toxoplasma gondii, a silent infection that lurks in meat and soil, passed through animals and humans alike. It infects nearly a third of all people on Earth, often without a single symptom, but it changes the brain. Reaction times slow, fear responses dull. In the Ice Age, when a single hesitation could mean death, that could have been fatal. Researchers at the U.S. National Institute of Allergy and Infectious Diseases found something remarkable. People with Rh negative blood reacted differently to Toxoplasma infection. Their nervous systems showed less impairment, as if their blood carried a built-in resistance to the parasite's manipulation. In a world where infection decided who lived or died, this tiny advantage could have been the difference between extinction and endurance. The theory grew stronger when scientists looked to the Black Death. Between 1346 and 1353, the plague killed nearly 200 million people across Eurasia. But the death toll wasn't evenly spread. Certain regions, especially those with higher Rh negative frequencies, reported lower mortality. Dr. Nicholas Wade of University College London analyzed records from Spain and southern France and found something eerie. Villages with high Rh negative prevalence survived at higher rates. The blood that once endangered childbirth may have saved adults from the deadliest pandemic in history. And when researchers from the Max Planck Institute for Evolutionary Anthropology cross-referenced modern genomes, they noticed another clue. Rh negative populations also tend to carry slightly higher traces of Neanderthal DNA, roughly 2% on average. That overlap raised an electrifying question. Was Rh negative not a mutation of modern humans at all, but an inheritance from our extinct cousins? Neanderthals lived in Ice Age Europe for hundreds of thousands of years, enduring brutal winters, parasites, infections, and scarcity. Their bodies evolved for resilience, not fragility. If the Rh negative trait came partly from them, it might explain its uncanny durability. a survival mechanism forged in cold caves and glacial winds. Whether it began in Neanderthals or early modern humans, its purpose seems clear: protection. Protection from diseases that shape the destiny of entire civilizations. Rh-negative blood may have been a biological shield, a mutation that demanded sacrifice in childbirth but granted immunity against invisible killers that swept through the world again and again. But that discovery only deepened the mystery, because when scientists followed the trail of this blood further back, beyond plagues, beyond recorded history, if you trace the world's Rh-negative hotspots, they don't form a continent. They form a coastline, a ghostly path that hugs the edges of the old Ice Age world. From the Berbers of North Africa, to the Basques of Spain, to the islanders of the Hebrides, and then, impossibly, to the Blackfoot tribes of North America. It's as though this blood once belonged to a people who lived by the sea, and when the sea rose, they followed it. At the end of the last ice age, the planet thawed fast. Ice sheets collapsed. Oceans surged more than 400 feet higher, and with every rising tide, the world we knew today swallowed the one that came before. Beneath the waves lie entire lost homelands. Doggerland, a rich plain that once connected Britain to mainland Europe. Sundaland, a vast Southeast Asian subcontinent now buried under tropical waters. And Beringia, between Russia and Alaska, once a frozen bridge, now a gulf of storms. These weren't empty lands. They were civilizations, hunting camps, villages, and trade routes that thrived for thousands of years. When the oceans took them, the survivors fled to higher ground, mountains, islands, and peninsulas that still carry their genes today. And wherever they went, the Rh-negative trait went with them. Archaeologists used to believe seafaring began only 5,000 years ago, but new evidence has shattered that timeline. On islands across the Mediterranean, tools made of obsidian, a volcanic glass, have been dated to over 8,000 years old. That means humans were crossing open water, trading goods and ideas, long before history remembers their names. If they could trade obsidian, they could trade bloodlines. And if those lineages carried Rh-negative blood, that could explain why the pattern doesn't follow land migrations. It follows currents. The Mediterranean, the Atlantic coast, the edges of lost Doggerland, the same places where Rh-negative frequencies still spike today. When geneticists model these dispersal routes, the picture that emerges looks less like random mutation and more like a memory of people pushed to the edges by catastrophe, coastal survivors who watched their world drown and carried their children inland to start again. But even that haunting vision doesn't explain everything, because somehow the same genetic thread also appears across the Atlantic, among peoples who, by conventional timelines, should have been completely isolated. The Blackfoot and Blood tribes of North America still carry Rh-negative blood at rates far higher than their neighbors, a fact that shouldn't be possible if all migration came through the Bering Land Bridge in the north. So how did this bloodline cross oceans before ships, before maps, before recorded time? Some scientists suggest founder effects, rare drift events, or ancient contact between early Atlantic seafarers and the New World's first peoples. Others hint, quietly, that the story of human exploration might be far older and wider than textbooks allow. Whatever the truth, one thing is certain: Rh-negative blood is not a relic of isolation. It's the signature of a humanity that moved, traded, adapted, and survived. But blood has always meant more than biology. In every era, it's been a symbol of power, a mark that rulers claimed as proof of destiny. And that brings us to one of the strangest chapters of all, the myth of royal blood. Throughout history, blood has been more than life. It has been power. Dynasties rose and fell on it. Kings claimed divine right through it, and empires wove myths around its purity. And somewhere in that long obsession lies a strange pattern, the shadow of Rh-negative blood. In medieval Spain, nobles prided themselves on pale skin through which blue veins shone beneath the surface. They called it sangre azul, blue blood. To the common eye, it symbolized superiority, lineage untouched by labor or sun. But to modern genetics, that phrase carries an eerie echo. High Rh-negative frequencies still cluster in those same Iberian regions where the term was born. Coincidence? Maybe. Or maybe those ancient aristocrats, unknowingly, were celebrating a trait that made them different, long before anyone could name it. Genetic testing of European royal mummies has only deepened the intrigue. Studies of Egyptian remains, including Tutankhamun's lineage, revealed markers consistent with Rh-negative ancestry. In Europe, the Habsburgs, the Tudors, the Bourbons all intermarried for centuries, sealing wealth and status within their veins. To have pure blood was to be chosen. To mix it was to risk chaos. And over centuries, that ancient bias survived, reshaping into superstition, nationalism, even conspiracy. Rh-negative became not just a genetic trait, but a mythic one, a sign of something other. But what if that sense of difference had a biological truth behind it? Not divine, not alien, just human variation taken to its extreme. When scientists compare Rh-negative and Rh-positive individuals, subtle distinctions appear, not in strength or intellect, but in sensitivity. Studies suggest slight differences in how the nervous system reacts to stimuli, sound, light, even temperature. Some report sharper intuition, stronger emotional awareness, faster reflexes under pressure. Not supernatural gifts, just a nervous system wired to feel the world a little more intensely. The gene variant responsible for red hair, MC1R, appears more often in Rh-negative populations, especially in Celtic regions like Ireland and Scotland, where both traits peak. In these places, as much as 30% of Rh-negative individuals also carry the red hair gene. It's as if these traits clustered together through millennia of isolation, each shaped by the same harsh climates and small surviving populations. Researchers from the University of California once noted variations in the blood-brain barrier among Rh-negative carriers, microscopic differences that may influence sensory processing. Perhaps those heightened perceptions once offered survival value, detecting storms before they struck, sensing predators, or reading subtle social tension within the tribe. Over generations, those differences could have meant life or death. But differences invite stories. And when science falls silent, myth fills the void. Rh-negative blood became a magnet for speculation. Some claimed it proved alien intervention, that an ancient species engineered a subset of humans. Others tied it to the lost civilization of Atlantis, arguing that its survivors carried their rare blood into the mountains of Europe. In Japan, where blood types are linked to personality, Rh-negative individuals are sometimes cast as enigmatic outsiders. The irony is that reality is stranger than any myth. Genetic sequencing shows Rh-negative isn't alien at all, but adaptability. And that adaptability still matters today. In today's hospitals, Rh-negative blood is more than a curiosity, it's a lifeline. Only about 7% of the world's population has O-negative blood, yet it's the universal donor, the type doctors can use in any emergency, for any patient. When a car crash victim arrives unconscious, when a soldier bleeds on the battlefield, when a child's surgery turns suddenly critical, O-negative is the first bag hung on the line. And because it's so rare, it's always the first to run out. The Red Cross warns that global O-negative reserves can drop to crisis levels in days. Every donation counts. Every pint can mean the difference between life and death. Pregnancy, too, remains a battleground. Since the discovery of ROGAM in 1968, most deaths from Rh incompatibility have been prevented, but not everywhere. In many parts of Africa, Asia, and Latin America, access to that medicine is still scarce. The The World Health Organization estimates over 100,000 newborns die each year from Rh-related complications that could have been prevented. Even in modern pandemics, the trait may still play a role. During COVID-19, studies at Johns Hopkins University, data suggested Rh-negative individuals had slightly lower risk of severe infection. Echoes of the same mysterious protection that may have shielded medieval villages from plague. It's poetic and sobering. A genetic relic from the Ice Age still shapes who lives, who dies, and who survives disease. The same blood that once doomed mothers and children now keeps trauma victims alive in hospitals around the world. Rh-negative blood has never stopped being a paradox, deadly and vital, fragile and powerful, a flaw of evolution that somehow became one of its greatest advantages. Look down at your hands. Inside those veins flows a record older than civilization itself. Every drop carries the story of survival, of Ice Age hunters clinging to life in frozen caves, of mothers risking childbirth without medicine, of entire villages that outlasted plagues and famine. Rh-negative blood isn't a mistake. It's a monument, proof that fragility and strength can coexist in the same body. It reminds us that evolution isn't about perfection, it's about endurance. Your blood is more than biology. It's a living archive of human triumph and tragedy. A lineage carried quietly through time, from the forgotten coasts of the Ice Age world to the royal courts of Europe, to the trauma wards of modern hospitals. So the next time you hear about blood drives or learn your blood type, remember what it represents. You're not just donating cells, you're passing forward the story of survival itself. Thank you for watching. Be sure to subscribe and join us for the next video, where we uncover more untold stories from humanity's past. Each episode takes us deeper into the mysteries of history, connecting us to the people and events that shaped our world today.